Haldane and the multi-compartment model. The birth of the submarine as a useful military tool created an enormous problem. How could the crew escape in case of an emergency underwater? This is why the British Royal Navy called in John Burton Scott Haldane, a physiologist and occupational medical doctor, to improve decompression procedures and produce more useful data for recovering trapped crew members. Haldane observed that the incidence of decompression sickness increased according to the exposure time up to a period of 5 hours, after which time there was no significant increase. Experiments using animals confirmed this observation. Therefore, if the human body had to be compared with a uniform tissue, its half saturation time must be such that it almost reaches saturation after 5 hours. Haldane estimated that this tissue had to have a half saturation time equal to 75 minutes, saturated to about 95% after 5 hours. However, on the other hand, even Heller, Mager and von Schrotter's tissue with a half saturation time equal to 9.7 minutes had had some success, even though it was limited to short exposure of up to 5 atmosphere. Haldane therefore established that the human body could not be represented by a single uniform tissue, but had to be considered as a unity of tissues. He created a mathematical model that simulated the human body with 5 tissues in parallel, with no gas exchange between them, with half saturation times equal to 5, 10, 20, 40 and 75 minutes. These tissues did not refer to any particular part of the body. They were simply mathematical expedients and were defined as compartments. Haldane's second important intuition was that the body could tolerate a condition of limited oversaturation with no problem. Seeing that dives of up to 10 meters, 33 feet, created no problems, Haldane conjectured that the halving of pressures was the maximum acceptable limit.